In this program, I have two conditions going on here. Within a loop, I have an ongoing series of instructions that are infinitely going to go on until the off button is pushed on the robot. And that is that motor C will go forward for 1 second and reverse for 1 second. Simultaneously, I have a case structure within that loop that says that if the sonar detector up here detects anything between 1 and 10 centimeters, then port A will be initiated. And if it's between 11 and 20 centimeters, then port D will be initiated. And if it's 21 centimeters and beyond, port D or A will cease to operate. So here we go. Let's move an object close in. We can see port A. I'm very close to the sonar here. If I pull this away, we can see that port D gets activated. And if I remove it completely, then port A and D stop. So let's take a look at how we program this. So essentially here we have our block diagram starting out with our larger loop. Inside that loop we continuously have running here motor C, which is going forward at power 75 for 1 second, then reversing minus 75 for 1 second, and then it goes back and starts over. It's continuously looping independently. And while that's happening, we have a case structure that if a certain condition is true, in this case, the sonar, if it reads between 1 and 10 centimeters an object, then port A will move forward by default, because we didn't specify a constant here, by default it's 75, it will move forward for 2 seconds, then stop. And if it's 11 to 20 centimeters, then it's port D that will move forward for 2 seconds and then stop. So let's take a look at how we program this. Now, normally I would create a new virtual instrument, but in this case I'm just going to work in this window and recreate the program directly below it so we can follow more clearly. So I'm going to go to the Mindstorms subset and then to programming and structures. I'm going to click on the while loop, drag that open, and then go back to the Mindstorms menu, and now I'm going to go to the input outputs and start off with our motor. Now sometimes it's interesting if you keep your spool of wire on here, then all the connectors blink and show you where you can click. So I'm going to go to the lower left here, click and say create constant, so it's positive 75, which is move forward, and up in the top middle here I'm going to click and choose constant, and I'm going to set that to motor C. And we want the motor to go forward for 1 second, so I'm going to go grab a wait for over here. And again, if I right click on the lower left corner, choose constant, I have it set to 1 second. And rather than going and getting those two similar commands there, I'm just going to take my pointer tool, grab these two, copy them, paste them, because I'm basically going to be repeating the same commands. The only thing I'm going to do is reverse this by putting a negative in there. So I'm going to do that now, put that at minus 75, and now let's wire all of these commands together. So I go to the top right to the top left, click, over here top right to top left, and there we go. So this is looped, and motor C will be moving forward for 1 second, and then it will be reversing for 1 second, and then it starts all over again. And this is just a series of commands running independently. Now we're going to create a case structure. So let's go back over here to our programming structures, and this time I'm going to click on case structure and just draw a box right down here. And you'll notice right now it's basically a Boolean option right here of true or false, and that's going to change in a second here. We're going to kind of elaborate. We're going to go beyond just a simple true or false. What I'm going to do now is I'm going to go back to the Mindstorms subset, input outputs, and I'm going to grab the sensor block. I'm going to switch this to read EV3 ultrasonic in centimeters. And now I'm going to wire this to the case structure. And when I do that, watch the true and false. It turns into a numeric value. And we have 0, which is basically false, and 1, which is true. But you can be more specific with that 1. So let's say we take our text tool here and we go into the 1. Let me just backspace here. Okay, right after the 1, immediately after the 1, I'm going to go period, period, and I'll put 10 centimeters and hit enter. Okay, so now we have 0, which is our default case. We have 1 to 10 centimeters, so when the ultrasonic reads something 1 to 10 centimeters in this space, something will happen. We'll specify in a second. If I right click on this field where it says 1 to 10 and I say add case after, you'll notice it logically suggests, well, 11 because 1 to 10 is taken, dot dot. I'm going to choose 11 to 20 centimeters, hit enter, and then I'm going to add one last one. Add case after, and this one I'm going to say 21 centimeters dot dot to 255, say. So now we have 4 structures here. 0 to default, 1 to 10, 11 to 20. And so basically, if any scenario is true, 1 to 10 centimeters, if an object is within 1 to 10 centimeters, we can ask the robot to do something. In this case, we're going to ask it to activate port A. So let's go to that structure and let's specify that. So, and just to show you, that's exactly what's up here. We're going to grab a motor forward, and I'm going to right click in the top center up here and say create constant. Go to my pull down menu, choose port A. By default, the power is at 75. If you right click here and create a constant on the lower left, it will automatically go to 75. You can put it lower if you want. Put it at 23 if you want. It doesn't really make a difference. It's just for the sake of demonstration. And I also put a time in there, a wait for, as you can see up here. I right click on the lower left, create constant, set that to 2. And finally, after 2 seconds, I'm going to break. So let's put a break in there. And the top center of that block, I'm going to create a constant. And again, specify that this is port A. Let's wire all of these up. There we go. Okay, now let's switch over and take a look at what we had for 11 to 20 centimeters. Basically the same thing, but in this case, it was port D, not port A. So if you want to save yourself some time, basically the whole sequence of commands here is identical except for the port. So I'm just going to select all of those, copy, switch over, paste, make sure I drop that inside here, and the only thing I have to change is the port. And now for the last case, we specified anything within 21 to 250 stop motors A and D. And we'll let C keep doing its thing. So let's go over here to 21 to 255. And I grab a brake motor, top center, create constant, specify the motor. In this case it's A, add another motor to that, motor D, and there. So we've got a stop on A and D in this situation. And in the case of our first case structure, which is our default case structure, if the sonar does not detect any objects at any distances, in other words, detection is false, then simply do nothing. Now for the end loop, you need to specify when the program will terminate. In this case, it is when the EV3 enter button is pushed. So I have to go get that and attach it to this stop condition. So I'm going to go to the complete set, sensors, and here it is, read the brick. I'll just connect that to the lower right. You see that green wire? And then you got to right click on the lower left, create constant, and it's the enter button. I'm going to delete this program right here. The only thing that's missing is I didn't specify on the ultrasonic connection that it was port 1. So let me just delete this here, move this up here, and let's specify that now. Right click on the center, create constant, and there it's on port 1. And now we're ready to download this program to our EV3 and run it.